Okay, so let's start our lecture today. So okay, so okay. I think last time we were trying to analyze the case where we have the lines like that, and okay, so oh yeah. So last time we were trying to see if we sum over yeah. So last time, so we are trying to analyze n from 1 to infinity. Sorry, this is n, and then this is n. N square a2 square minus m square a1 squared over 4n square a2 square plus m square a1 square. Okay, and we are letting the okay, I think I'm letting a1 equal to a2. Okay. Yeah, and then I'm trying to analyze what happened. So let's bring it in. So let's make it as star. So star is equal to summation m from 1 to infinity, summation n from 1 to infinity, n square a2 square minus m square, so minus, so 4m square a1 square, okay, over 4 times n square a2 square, okay, so m square plus 4m square a1 a2 square, okay. So then we subtract the, wait, what I'm doing, so this is a2 square, okay, and then we divide by yeah, so this is n square minus 4m square, and then 4, so becomes a2 plus okay, so 4m square a2. So okay, so in this case n is equal to 2m. Okay, so So the zeros are exactly n equal to m. Okay, so okay, so let's draw this line like this is x, right? So yeah, x equal to y. So like yeah, like this line, okay. Okay, so okay. So for the points, let's say here, yeah, so I want to find some cancellation here, right? So how do I really find some cancellation? Start from here. Okay, let me think. Okay, so let's do this. So let's okay, so let's divide this region into two parts. Okay, so one part is the part that's okay, so let one to be equal to the set of all n comma m, where n is where m is bigger than 2n. Okay. No. M is bigger than 1/2. Okay. Yes. So and then and 2 to be the set n m, and m is less than 1/2. Okay. So let's do that, and then okay. So for this point, let me think. Oh, okay, yeah. So let's see. Let's just try this. Okay. So so let's start with the region 2. Okay. So start with. Okay. So okay. So what is our goal? Okay. So our goal is basically is to just sum over. Okay. So write the points as infinite series. Okay. Like horizontally and vertically. Okay. So by horizontally, I mean yeah. So and vertically. Okay. So horizontally, I mean like you start with the line m equal to 1, right? Okay, so let's say in 2, let's start with m equal to 1. Okay, so then we have okay, so when m equal to 1, so this n start from what? N start at 3, right? Okay. Okay, so this is the point where this n squared minus 4m squared is positive, right? Okay. Because okay, so this is the region 2. Okay. Okay. And value is okay. Okay. Okay, so this is m equal to 1. Okay, so for m equal to 2, okay. So m equal to 2, this n start at 5, right? Okay, so okay. So then this m is being summed to what? So if we have for any arbitrary m, right? Then this n start, I think it should be 2m plus 1, right? Yeah, start at 2m plus 1. And then 2m plus 1 to infinity, okay. So yeah, so and yeah, this is positive. Okay. And then in 1 we have okay, so now let's sum vertically here. So this is the sum from okay, so for each fixed n, right? Yeah. Yeah, I think this is a little bit tricky here. So for each fixed n, is that Okay, so for n equal to 1, it starts at 1, right? And for n equal to 2, it starts 3. Okay. Okay, so n equal to 3, it starts. Wait, where does it start? Okay, so it should also start at 3, right? Yeah, it should also start at 3. So, and then so n equal to 4, it starts. 4. Okay, it starts 4. So, wait, it starts. Okay, sorry. Yeah. So, yeah, sorry. Let me. So, okay. So n equal to 1, we have m start at 1 to infinity. Okay. Okay, so m squared minus 4m squared. Or actually, it's being reversed. Right. So in this case, yeah, it's actually negative. Okay. Yeah. So let me yeah. Let me just uncopy the numerator, copy the same denominator, and so n equal to 2, it starts at 2. Okay. Okay. And 4 squared, and n equal to 3, it all starts at 2. Okay. Okay. So n over 2. Okay. Okay, I think the pattern is, so for each n, right? So basically you are taking n over 2, and then you take the highest integer that you take the bottom next, you take the, so yeah, so basically you take the closest integer to it, right? So basically here the closest integer is the closest integer either like equal or underneath the over 2, right? So the closest integer equal or underneath over 2. So let's use this symbol, okay? So the closest integer that is equal or underneath n over 2 plus 1. Okay. Of n squared minus 4n squared. Okay, so the integer equal to underneath. Over T. Alright, so okay, so yeah, yeah, let me just stop here. Okay. Yeah. Yeah, sorry. Yeah, so today I'm starting a little bit late, so I have to end right now. Sorry.